Ladies, sorry that we did not have time to complete your notes in class today, so I appreciate you tuning in this afternoon or tonight or whenever you're looking at these notes. So we're in Chapter 2, Section number 1, and Goal 3. We're going to solve quadratic equations that have complex solutions. Remember, complex values are in the form a plus bi. A is your real number and bi represents the imaginary unit. Example number 1 is a quadratic equation, x squared plus 32 equals 0. And let's think about how we solve quadratic equations. We can factor, we can use the quadratic formula, and if we only have one variable in the equation, we can isolate that variable. For example number 1, we only have x squared. So it is possible to isolate x squared, and I can do that by subtracting 32 from both sides of the equation. And we now know that x squared is equal to negative 32. Well, how do you solve for x? You would take the square root of both sides. X is equal to, let's think about how do we reduce the square root of negative 32. We know that negative 32 is negative 1 times 32. Negative 1 is 16 times 2. And if we take the square root of each of these, the square root of negative 1 is I. The square root of 16 is 4. And then square root of 2 is reduced as much as possible, so it would stay under the radical. And then the last thing we need to remember is that when we take the square root of both sides, we're solving for all solutions that could be plugged back into x and give us negative 32. So we know that that would be both positive 4i on the square root of 2 and negative 4i on the square root of 2. I'd like you to pause the screencast and complete number 2, and then turn it back on and check your answer, please. Number 2, we also have one variable, x squared, so we can isolate that by subtracting 100. Take the square root of both sides, and both positive and negative 10i are equivalent to negative 100. In example 3, I have x to the second and x to the first. So it's impossible to isolate the variable because we have more than one. These are not like terms, so we cannot add them. So let's first look at the quadratic and think about factoring it. And if you try to factor 9x squared minus 6x plus 37, you may be successful. But my guess is you're looking at the 9 and the 37, you're thinking, oh, those are huge numbers. I don't want to deal with trying to factor it. So what is another option to solve quadratic equations without having to factor, especially if the numbers are a little bit troublesome like these? I hope you said the quadratic formula. Using the quadratic formula, we need to identify A, B, and C. In this case, A is 9, B is negative 6, and C is 37. Okay, so with the quadratic formula, we know that x is equal to the opposite of b plus or minus the square root of b squared. Negative 6 squared is 36 minus 4 times a times c, all of which is divided by 2 times a. And notice I'm splitting this into two fractions. I believe somebody in your class taught me to do that. This helps us keep from butchering later on. So let's double check. Opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a, and both terms are being divided by 2a. So let's see what we have. 6 divided by 18 plus or minus the square root of Okay, I definitely cannot do that in my head. Let's see what that is. So 36 minus 4 times 9 times 37. So that gives us negative 1,296. 36 minus 4 times 9 times 37. Yes, so negative 1,296. All divided by 18. Now, I am giving you permission to find the square root of negative 1,296 using your calculator, okay? I do not give you permission to type in this entire problem and let the calculator do the work for you, but I will give you permission to simplify this huge radical. So let's see what that is. So we will take the square root, whoops, wrong place. Let me try again. I think I used the wrong key. The square root of 1,296. Okay, it's not going to take care of the negative for us, so let's go in and delete the negative and take the square root of positive 1,296, and that is 36. So what does that mean? That means we have 6 divided by 18 plus or minus 36i, all divided by 18. Now remember, we were not able to find the square root of the negative, so we took the negative out and let the calculator tell us that the square root of positive 1,296 was 36. So you've got to remember to go back and do the I in that case. So let's reduce now. 6 and 18 will reduce to 1/3, plus or minus 18 will divide into 36 2 times, so plus or minus 2i. And these are our solutions for our quadratic. 9x squared minus 6x plus 37 equals 0. For number 4, we have a quadratic, but if you'll compare number 4 to 1, 2, and 3, you notice that number 4 is not yet equal to 0. Before you solve a quadratic equation, it's important that that quadratic is equal to 0. So let's do that now. We would add 2 to both sides, and we are now solving for x squared minus 2x plus 2 equals 0. And you could try to factor here, but you would quickly realize that x squared minus 2x plus 2 will not factor. So I want you to pause the screencast, plug the information into the quadratic formula, and then come back and check your answer. Okay, so we took our function and plugged it into the quadratic formula. X equals the opposite of b. B was negative 2. So the opposite of b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a, or 2 times 1, and over 2 times 1. So 2 divided by 2 is 1. 4 minus 4 times 1 times 2 is 4 minus 8, which is negative 4. The square root of negative 4 is 2i. And 2i divided by 2 gives us a final solution of 1 plus or minus I. Ladies, I hope this helps you as you solve quadratic equations with complex solutions. Thanks for checking in today.